Well, here we are at CA 8. If you're following along in the series, this is the 8th video. This is chapter 1.4 in the textbook that will be linked in the description below. The topic is polynomials. It's pages 60 to 66, and we are going to talk about how to add, subtract, and multiply polynomials. We're also going to look at the FOIL method, the perfect square trinomial formula, and the formula for a difference of two squares. Most of this stuff should be pretty familiar to you at this time. I know it's going to be a lot of information, but you should be pretty comfortable with most of it. So it's not going to be so bad. Let's get started. First, let's cover these terms so that when I'm saying them, you don't think I'm talking Greek. A polynomial. Poly means many. Nomial means number. So this is many numbers. We're going to be looking at variable polynomials, so we'll look at some examples in just a second. Now, a term is a number times the variables and their exponents. Your coefficient is the number in that term. So here's an example. This is a polynomial. It has two terms in it. This is a term and this is a term. So within this term, you've got 2 times x squared times y. They're all multiplied together. That's why they're one term. Here is 7x. It's multiplied together. That's why it's one term. Now when you put pluses and minus signs in between your terms, that's when you form a polynomial. The coefficient is your number. In this term, the coefficient is 2. In this term, the coefficient is 7. And if there's not a number there, like if you just have x, y to the third, this has a coefficient, and that coefficient is the understood 1. We have some subsets under the term polynomial, and the first one is monomial. Mono meaning one number. So an example of a monomial would be 2x squared y. Everything's multiplied together. Alright, binomial means two numbers or two terms. There's going to have to be one plus or minus sign in here somewhere. I could have 2x squared y plus 4. That's a binomial. The other term doesn't have to have a variable, but it could. I could have 3x squared y minus 7z. That's a binomial. A trinomial is, you guessed it, 3 terms. So how many plus or minus signs are we going to have in a trinomial? 2. It could be 2 pluses, 2 minuses, or one of each, but you're going to have 2. So an example would be 3x squared plus 5y minus 7a. This is a trinomial. Here's term 1, term 2, and term 3. Now what about bigger than a trinomial? Oh yeah, they exist. We just don't have a special name for them. So polynomial is what we refer to anything larger than this. And to be honest, well, except for the monomial, your binomial and your trinomial, they are also polynomials. We just have special terms for these because we use them so often and it helps us out. So let's look at 3 more terms real quick, and this is from example 1, page 61. We've got 3 terms to look at: degree, leading term, and leading coefficient. The definition of degree is it is the highest power in your polynomial. Leading term is the term that has that power, that highest power, and the leading coefficient is the coefficient of your leading term. So it's easiest just to look at some examples. Here I have 3 plus 2x squared minus 4x to the third. What is the largest power in that polynomial? Well, that's your 3. So the degree of that polynomial is 3. Alright, what term has that power? Now remember, a sign belongs to the number that comes right behind it. So when you look at this term, you should see 4x to the third. That's going to be your leading term. Then your leading coefficient is the coefficient of this term. So that's going to be negative 4. Now usually when you have a polynomial, it is standard practice to put that polynomial in a certain order, and that order is with your leading term first, and then your exponents go in descending order from that. So this polynomial right here, sometimes a problem will tell you to put the polynomial in order or in standard form, and that means you start with your leading term. So to be in standard form, this should be negative 4x to the third. Your next term is going to follow the power order. So you look for your variable, that leading variable is x to the third. What power of x comes next? The plus 2x to the second and the plus 3. So sometimes a problem will ask you to reorder the polynomial from leading coefficient on down. So that's what you would put there. Anyway, the next problem, and I've written all through my exponents here, says 5t to the fifth minus 2t to the third plus 7t. So what is the degree of this polynomial? Well, the largest exponent is 5. The term that has that exponent is 5t to the fifth. So your leading coefficient is 5, this 5. And then our very last one, 6p minus p to the third minus 2. Highest power in this polynomial is this 3. The leading term is the term that has that power, so that's negative p to the third. Now, what's my leading coefficient? Remember, I've told you, if you don't have a coefficient, it's the understood 1. So your leading coefficient here is going to be the negative 1. Okay, let's look at some applications of this. Now, when you add or subtract variable terms, remember, exponents do not change. Coefficients change, but you use the variable portion to match, and then exponents never change. They all stay the same. This is example 2 on page 61, and we're asked to find the sum, and this is what your problem looks like. And you see the separation of the two parts by parentheses. You cannot perform any of the operation or the simplification inside the parentheses. That's the first thing you want to check for according to PEMDAS. So there's nothing I can add together here, and there's nothing I can combine in this. So we're left with it as it is. Now, since everything is added together, technically what you're doing is you are distributing the 1 that's outside of here into the set of parentheses so that you can drop the parentheses. So like I've said before, I don't want you to think you can just willy-nilly start dropping parentheses, but that's what we're doing. Now, when you distribute a positive 1, you're not going to change the value of anything. So now, this is what our problem looks like. And there's no parentheses, so we can use the commutative property and we can match up terms and then combine them. So let's start with the first one. Do I have anything that matches 12x squared? Well, I have 8x squared, and when you add the two of those together, you get 20x squared. Remember, I said the powers don't change. The exponents do not change. Now let's go to 9x. What else matches 9x? Well, I've got a minus 5x down here. So what's 9x minus 5x? That's a positive 4x. Okay, the next thing is a constant term, 21. And then I have a 20 down there. Now this is negative. So when you add negative 21 to positive 20, you get minus 1. And what do I have left over? Well, I've got that positive 4x to the third. Now, I want to put this in standard form, even though they don't ask for it, but let's put this in standard form, and that means picking out the highest degree and putting it first. So I'm going to put my 4x to the third first. That gets rid of it. Now, what's my next power of x? The positive 20x squared. What's next? The positive 4x. And then last is that minus 1. So this is going to be your final answer. Here's example 3 on page 61. This one's a little bit different. It says find the difference. And this is going to highlight what I was telling you about how to get rid of these parentheses. First, look inside the sets of parentheses and be sure that you can't combine any terms, and we cannot. Now, to actually get rid of the parentheses, I'm going to distribute whatever's in front of it. What's in front of this set is a positive 1. So nothing here is going to change. It's just like it is. Now, with this set, what's in front of it is this minus sign. So I have to distribute all the way through. Now, a lot of people do this in their head, and that's perfectly fine. I just like to write everything out so that I don't make any careless mistakes. So when I distribute this minus sign, this is actually positive right now, but when I distribute the minus, it becomes minus or negative. When I distribute this minus here, it changes to plus. This plus sign is going to change to minus, and this plus sign will change to minus. Now I have one long string of numbers to combine, and I'm going to go through it just like I did the last time. Let's start down here on the left. Will anything match 7x to the 4th? No, it doesn't. So it's going to stay just like it is. Now, what matches the x squared? Well, I have a minus x squared and I have a plus 2x squared. When you combine those terms, you get a plus 1x squared or just x squared. All right, next I have a 6x and I have a minus 3x. 6 minus 3 gives you a positive 3x. And if you notice, I use the same number of lines under matching terms. That way I can tell that I've used everything and I can easily go back and see what I combined. When you get into upper levels of algebra, your problems get longer, and being able to go back and see what you did is extremely helpful when you're looking for your mistakes. Here I've got this plus 1 and I have a minus 2. So plus 1 minus 2 gives me minus 1. Now I have this left over, nothing to combine with it. Alright, now let me go through here and put these in order, starting with my leading coefficient or my leading term. That's going to be the 7x to the 4th. My next exponent is this x to the 3rd, so I'm going to have minus 5x to the 3rd. Next is the x squared, and remember, a sign goes with the number that's behind it. I have a plus 3x and I have minus 1. So that's going to be your final simplified answer right there. The next topic is another subset of what we've been talking about. And this is the perfect square trinomial, otherwise known as the PST. This is a certain trinomial that you get when you multiply two binomials that are just alike together. So first you need to understand x plus 3 squared expands into x plus 3 times x plus 3. It is not x squared plus 3 squared. So I want you to get that in your head right now. X plus 3 squared is not x squared plus 3 squared. You have to perform the operation that is inside the parentheses before you can do the outside exponent. And if you do this, you've distributed that exponent within a sum. You can't do that. Now, if these two were multiplied together, that'd be a different story. But when they're added, you have to add them first before you can square them. And since I can't do that, you expand it. So expanded form of x plus 3 squared is x plus 3 times x plus 3. Now let's just look at what happens if you FOIL this. I'm going to get x squared plus 3x. That would be those, plus another 3x, plus 9. So I get x squared plus 6x plus 9. Now that's what your answer looks like. Here's the formula for a perfect square trinomial. And you can use this backwards and forwards. Like I said, a lot of this stuff in this section is a precursor to what's coming in the next section. We're mainly learning to combine, add, subtract, multiply in this section. In the next section, we're going to factor. So we're going to be taking the trinomial and breaking it up. If you have if you have a binomial squared right here, you get an answer in this format. So what does that mean? Well, if this number is a, What would a squared look like? Let's relate it to our problem we worked. If this is your a, what's a squared? If a is x, your answer would be x squared. Let's look at the last term. In the formula, it says the last term is b squared, where b is this number. Well, my last number was 3. Isn't 3 squared 9? Yes. The hardest one is this middle term. In our formula, it says 2ab. That means 2 times the first term times the second term. So let's look at our problem. What would 2 times the first term times the second term be? 6x. And that's what I got in the middle. So the formula will save you some time. Let's look at an example. Technically, the perfect square trinomial formula has 2 versions, one for plus and one for minus. If you have a plus b, this is your answer. If you have a minus b, this is your answer. If you will notice, the only difference is that this sign, this first sign, matches the sign that's in your binomial. Everything else is the same. Because of this, you don't even have to worry about the sign in your answer. It's already taken care of you. So, let's go to this. Example 6, page 65 says expand 3x minus 8 squared. Alright, if I match it to my formula, this is a and this is b. So let's see how it would fill into the formula. Well, a squared, and I'd be using the bottom one because it's minus. So a squared is going to be 3x squared minus 2 times a, which is 3x, times b, which is 8. Then, and like I said, since your formula already takes that into consideration, you don't even have to worry about the sign. Alright, the last sign is a plus. B squared is going to be 8 squared. Alright, now let's simplify this. What is 3x squared? 9x squared minus, alright, 2 times 3 is 6 times 8 is 48x, and then 8 squared is 64. So that's going to be your final answer. Now, would you get the same answer if you took this and expanded it out and did the FOIL method? Let's see, 3x minus 8, I would have to expand that out. Then I would use FOIL. 3x times 3x is 9x squared. The outside is negative 24x. The inside is negative 24x. And my last two is positive 64. These two would combine, so I still get 9x squared minus 48x plus 64. So yes, this is another redundancy, and understanding the formula is going to help when we use it backwards. We're going to learn to recognize a perfect square trinomial, and then it's going to be super easy to factor it. So just pay attention to the formula, use it wherever you see a binomial times itself or a binomial squared. Next, we're going to do a little discovery of our own. I have 2 problems up here, x plus 1, x minus 1 times x minus 1, and x plus 5 times x minus 5. Now, do you remember when we talked about conjugates? Conjugates have the same numbers but opposite signs. So for both of these examples, what you have is conjugates multiplied together. So let's use FOIL on those and see what happens to the answer. When I FOIL this, I get x squared minus x plus x minus 1, which these two cancel out, minus x plus x, so now I have x squared minus 1. Alright, let's try this one. I've got x times x is x squared. I've got minus 5x. I've got plus 5x. And then I've got minus 25. These two subtract out. So now, once again, I have x squared minus 25. So look at the similarities between our 2 answers. They both only have 2 terms. And the terms, each term is the perfect square of the 2 numbers in my conjugates. This is a perfect square, this is a perfect square, and their square roots are the numbers in your conjugate. That is the difference of 2 squares formula. That's how it was derived. people just worked these problems over and over and over, and they saw this relationship. So your formula for a difference of two squares is that a plus b times a minus b is equal to a squared minus b squared. And you could have these in different positions. It's just you have to have two conjugates multiplied together. Then what you wind up with is the square of the first number minus the square of the second number. So let's look at how this applies to a problem. What if I had x plus 2 times x minus 2? If you recognize right off the bat that this is two conjugates multiplied together, you don't have to use the FOIL method. You can just say, well, I know that's going to be x squared minus 4. Your answer is the difference of two squares. So let's do example 7 on page 66. Our problem says expand 9x plus 4, 9x minus 4. Now if you are on your toes, you immediately recognize, hey, I've got two conjugates multiplied times each other, so I can use my formula. If you don't recognize that, you're going to have to use FOIL or distribute, and it's going to take a little bit longer. But since I recognized it, all I have to do is say, I know that this is going to be equal to the square of the first term, which is 81x squared, minus the square of the last term. Okay. If you don't believe me, you go through here and you FOIL this, and you will see that the opposite signs are going to make your two middle terms subtract out, and then you have a negative sign for your last one with the square. Okay guys, this is our last example for this section. And what we have here is x plus 4 times 3x minus 2y plus 5. So this is just an any size polynomial times an any size polynomial. And you just need to be sure that you multiply this first term times everything in here, and this term times everything in here. You can do 4 times 4, a 4 polynomial times a 4. You can do 20 and 20. However long. You just have to break up that first set of that first factor, and multiply it times everything in here. Usually you can do this in your head. If it's got a lot of numbers, I'll show you how I do it then. I take my first number, x, and I multiply it times this whole set of parentheses. Then I take this sign and this second number and I multiply it times this whole set of parentheses. Now do you see what I did? This number went here, this number is here, and this are just repeats of that second set. Now that you have it broken down, you can just use a distributive property. And like I said, on this one, I wouldn't have written this down. I would have just come up here and done the lines to make sure I multiply everything, but you get the same answer. Alright, so x times 3x is 3x squared, and x times a negative 2y is negative 2xy, and x times 5 is 5x, watching your signs. Now I'm through with that, so I can come down here. 4 times 3x is going to give me plus 12x, and 4 times minus 2y is going to give me negative 8y, and 4 times 5 gives me positive 20. Now, I need to go through here and add the terms that match. Nothing matches 3x squared, so it's going to come down here by itself. Minus 2xy, there is nothing else that matches it, so it's going to stay. Then positive 5x plus positive 12x, I can combine to be positive 17x. Remember, when you add, you don't change exponents. So x plus x is not x squared. It's just x. Then, let's see, let me put 3 under each one of those. Alright, here I've got this 8y, which is negative, and then very last is that plus 20. So, that is going to be your final answer for that example. Now, what I would do if I were you is on page 67 and 68, that's where your problems are, I would like for you to work multiples of 3. a lot of this should have been familiar. I know a lot of it is redundant. So do multiples of 3. Check your answers in the back. If you have trouble, go back and work some more problems or let me know. Okay? And I will see y'all in CA 9. We're going to get into factoring, so that should be fun. I'll probably break that up into several videos. See you later. Bye.